This puzzle is called Tiny Entropy by AnalyticalNinja, another one of their 4x4 puzzle series. I got it from the Sudoku testing submission channel of the CTC community Discord. Let's take a look at the rules. So standard 4x4 rules, of course. Cells connected with purple lines contain non-repeating strings of consecutive digits. This is also known as Renban lines, so these three digits will, as a set, all be consecutive with each other. So we could have, well, I guess in 4x4, there's only two options. It's either a 1-2-3 pair, or a 1-2-3 triple, or a 2-3-4 triple. We could not have this be like a 1-2-4 because this is not consecutive. 1 and 2 are consecutive, but 2 and 4 are not. So it's not a set of consecutive digits. Yeah. So I guess with 3 length, there's only 2 options. So that's probably a big clue for this puzzle. Global entropy. Every 2x2 square in the grid must have 2 low digits from 1, 2, and 2 high digits. Okay, so I'm not super familiar. I've tried a couple 3x3 puzzles like this, but I've never been able to really figure it out. Although 4x4 is probably a good introduction to this idea. So let's say that we had, this is a 2, this is a 1. No, how should I do it? If this is a 2, this is a 1, and then these two digits must both be large digits, I believe, because we have this 2x2 here. We have 2 low digits already, so this must be 2 high digits to work this out. Digits can repeat, so like this would be valid, like 1, 2, and then 3, 3. Because it's just too low, too high. It doesn't matter if they repeat. Of course, in a 2x2 box, they're not going to repeat, but across a line like this, or in this middle section, it could even be probably 1, 1, 3, 3, or something weird like that. And then let's see, the last one, the gray circle is odd, so this must be a 1 or a 3. That's what odd means. Yeah. So I think that's all the rules. It's probably pretty easy, so give it a try. If you want, I'll put a link to the puzzle down in the description. Let's get going. So, yeah, so I said at the beginning, this is either 1, 2, 3, or 2, 3, 4, which means this is either a 1 or a 4 on the end, as is this, because there's this triple looking ends. So this must be 2, 3 or like this. So that makes this 2, 3, this 1, 4 just by Sudoku. If this is a 1, 4, this must be 2, 3 once again, which makes this a 1, this a 4, this a 1. I haven't used that global entropy constraint at all yet. Oh, this must be 4. There's a 1 over here, 4 over here. One of these is a 2, 3. One of these is a 2, 3. Maybe that's where I'm going with this. I don't know. Let me think. Yeah, I think that must be how we differentiate the 2s and the 3s, huh? Now that I'm thinking about it a little bit more. Because otherwise we wouldn't know how stuff is arranged. So, like here, the only high digits possible are 3s, because we already put both 4s in these columns. So this must have 2 3s in it. There must be a 3 in here, of course, because it's a 2, 3 pair, but this also must have a 3 in it. Because we're going to have a 1 on this side and a 2 on this side, but that's the 2 low digits. We can't put another 2. Yeah, that makes sense to me. So this is a 2, this is a 3. Whoops, type that in backwards. So this is a 3, these are not 3s. Okay. Now we have 2 high digits here, so this must be 2 low digits, so this must be 1, 2, 3. This is a 2, this is a 3, this is a 4, which then sets that. Yep, there we go. That was a pretty cool puzzle there, AnalyticalNinja, Tiny Entropy. Yeah, this clue, or this constraint, the global entropy, is always kind of, I don't know. I don't have any experience with it, so it's really hard. Luckily, 4x4 I was, kind of out of other clues to look at there, so I knew I had to look at that, but yeah, that's a hard one for me. How'd you guys do? Thank you, AnalyticalNinja, for this puzzle, and thank you all for watching.